So for today, it's going to be a review of like rational equations. It will be a review of radical equations with the square roots, cube roots, and we'll be solving like linear equations. We'll be solving quadratic equations. We're going to have to factor today, okay? So for prior knowledge here, we have the solving equations by reversing the order of operations. So remember, this is when I had you do, please excuse my dear Aunt Sally, in reverse. So first we get rid of any addition or subtraction that's outside the parentheses. So first get rid of addition or subtraction. And then the second thing you want to do is get rid of multiplication or division is the second thing you want to do. But we're looking at anything outside the parentheses that involves multiplication and division. And then it'll bring you to like whatever's inside. It says parentheses, but like even if it's a square root, anything inside the square root. So then once you get to like the square root portion or cube root or whatever, then you cancel the root by doing the exponents. So like if it's an x squared, you would take the square root of each side. If it's a square root, then you square each side, just depending on what you're doing, okay? So you do all of that outside of the parentheses, and then basically you repeat it on the inside of the parentheses. So you follow the same order. First, get rid of addition and subtraction, then multiplication and division, and then you get rid of exponents inside the parentheses, okay? So let's look at our extraneous solutions now. Extraneous solutions, if you guys remember, we had the square root equations, and then we also had the rational equations. The square root equations will have extraneous solutions if you have like a false statement or it produces imaginary values. So if we ever have a square root with an x on the inside, that's when you guys have to check your solution. And if you get like a false statement like 2 equals 0, that is a false statement. So whatever you plugged in would be extraneous. Or if you get anything that's imaginary, like the square root of a negative would be imaginary. Anything producing imaginary values would be extraneous. And then we had the rational equations. So rational equations look like 9 over x or something. If we have a variable in the denominator, it's rational. The only way you'll have extraneous solutions is by dividing by 0. So you cannot have 0 in the denominator. That's when we looked at the excluded values. Excluded values. So in this case, x cannot equal 0 because we cannot divide by 0. Okay? Those are the two different ways that we could get extraneous solutions. If we have square roots and we check it, we get something that's false or imaginary. The other way we get extraneous solutions if we have rational equations, dividing by like variables in the denominator. And then you check excluded values. So let's go ahead and look at our first example here. You guys want to attempt to solve this one, or you guys want to?
I think we should go over it.
Go over it? Okay. So the directions here says to solve the equation and then determine whether the solution is valid or extraneous. So go ahead and copy this one. 5 times root x equals 45. Okay, so do I have a square root or what's a square root, right? So because I have a square root, I am going to have to check for extraneous solutions. But remember, this is when we do like, please excuse my dear Aunt Sally in reverse. So first check, do I have any addition or subtraction to get rid of? Do I have any addition or subtraction on this side? Nope. So then you check multiplication and division. Do I have multiplication and division here?
Wait, what was the question?
Eyes up front. Side conversation needs to stop, please. Notice I have my x right here. That means I have to get rid of the 5 in the square root. But you follow it in this order. We didn't have addition and subtraction. Do I have multiplication and division?
Yeah.
Yes. Which one do we have?
I still read the 5.
Right now, if they're touching, what operation is that? Multiplication. So how do I undo multiplication? You divide. So divide both sides by 5. Those cancel. We get root x equals, what's 45 divided by 5?
That's
9. Okay, and then how do I get rid of the square root?
You put, you do the same thing as 9. Square root 9.
Square root in it? Well,
Or,
No, you the exponent thing.
the exponent, raise it to what power?
Power.
To the second power, right?
Oh, that's wrong.
So square root cancel out the squared, and I get x equals, what's 9 to the second power?
81. Okay, bro.
81. Okay. Then I need to check it. Because I have a square root here, I could get an extraneous solution. So you guys need to check it. So in order to check it, you have to plug in x equals 81 into the original equation. Okay. So my original equation, I had 5 times the square root of x. But I found 81 for my x. And I'm checking to see if that equals 45. Well, remember, when you're checking, you do not do anything to the right side. So leave the 45 alone. You're going to simplify the left side and then see if it equals the 45 on the right side. Okay? So if I simplify, what's the square root of 81?
9.
And 5 times 9?
45.
45. Did that equal this side?
45.
Yeah.
Yes.
Yeah.
So that means it's valid or extraneous?
Valid.
Valid. My 81 is valid. Okay, so when we're solving, you want to get rid of basically everything that's not inside the radical. Then undo the radical, and then once you have a solution, go check it, okay? Let me see something really quick.
You got a whiteboard.
Okay, so again, you guys are trying this one. Oops, my bad. Square root of x plus 2 with the plus 8 on the outside equals 2. So remember, PEMDAS in reverse. Please excuse my dear Aunt Sally in reverse. See if you guys can solve this one. So here's the solution in case if you guys, you guys all had it, but I don't know if you guys all got it on the paper or not. Here we subtracted 8 was negative 6. Square edge 36. Then subtract 2 is 34. Check it, and it ends up being extraneous. Okay? All right, next one you guys are going to try. Somebody said they want to try it. That way, the points wise, we'll see if you guys can do this one. See if you guys can remember what to do here as a group. You guys do it together. So here's this one. Again, you have the variable in the denominator. So what's the LCD? I'll help you guys get started, but you guys can finish it. What's in the denominators? 1 and x plus 4 is in the denominator. Yes, it's the denominators. Least common denominator. So x plus 4 is in the denominator. So what's my excluded value? What x cannot equal?
0.
What would make this a 0? A negative 4. Good. So the excluded value, you just cannot get a negative 4 for your solution. Okay? Shh. So multiply both sides by the LCD. And then go solve as much as possible. And then check your excluded value. Okay? So after you get to this step, you need to move the x's on one side, move the numbers on the other. You want to do a positive x. So what would give me a positive x if I subtract 2x or subtract 3x? A positive value. You want to subtract 2x to each side. And we get 8 equals, what's 3 minus 2x? And then plus 12. Now my x's are on one side. Now I have to move the numbers on the other. So how can I get this 12 over to this side? Subtract 12 to each side. And that's going to give us x equals what? Negative 4. So if you check it, you're supposed to check the excluded values. Is negative 4 an excluded value? Yes. Negative 4 is excluded value. That is what I got. So that means that this is extraneous. So because that's extraneous, that means we actually have no solution. Okay? All right. The next one is not going to be like that. The next one, but I think this next one's totally doable. It's nothing complicated. So next one, you ready? Okay, next one, please copy this one. Shh. This is doable. Like, there's no fractions. There's no nothing. So I'll explain what to do, then you guys can attempt it. Ready? So, shh. Well, maybe I should wait for you guys to copy it. Go ahead and copy it. Okay, so for these, you guys want to distribute the 7 and then distribute the 4. And it's going to be pretty much what we did on the last example. Get the x's on one side, get the numbers on the other to solve for x, okay? So you guys go ahead and try this one. Through it because some of you guys were stuck on it. So if I distribute the 7, that'll give me 9 plus 7x plus 14, yes? Shh, quiet please. Equals 3 plus 4x minus 16, yes? Okay, when you get to this step, you have to combine all of your like terms together. So like here, for example, a 9 and a 14, those don't have variables, so I can add those together. What's 9 plus 14? What is it? 23? Plus 7x equals, shh, can you guys quit the talking, please? Shh. Okay, then on the other side, I have the 3 and the negative 16 are like terms, so you can combine those together. What's 3 minus 16? Negative 13. Then when you get to this step, you want to move all the x's on one side, the numbers on the other, okay? So if I do that, what do I move over first? Minus 4x. Shh, quiet, please. We get 23 plus 3x equals negative 13. Shh. And then what do I do next? Minus 23 on each side. We get 3x equals, that's a negative 36. We divide by 3. Gives us negative 12. Now to check if it's valid or not, like you don't really even have to check it because do you have anything in the denominators? Do I have any variables in the denominators? No? Do I have any square roots? No, so I don't even have to check it. That's just going to be my answer. But if you want to check it, you just plug in negative 12 and see if you get this side equal to this side. Okay? But you don't have to actually check it because we don't have any. Shh. We don't have any variables in the denominators. We have nothing here in the denominators. And I don't have any square roots. So then I do not have to check for valid or extraneous. I'm good? Okay. All right, so I'm going to have you guys go ahead and wait, let me see what the next example is. Yeah, you guys can, the next one's not bad either. So next one, you guys can attempt this one. All right, here we have x over 9 minus 4 is equal to -1. You guys go ahead and try this one. This one is actually just PEMDAS in reverse, so please excuse my dear Aunt Sally. In reverse. First, get rid of addition or subtraction, then multiplication and division. No, but it's because I'm recording. I'm recording, so I gotta do it. So we're gonna add 4. We get x over 9 equals. What's -1 plus 4? -1 plus 4. And then what do you do after? Multiply by 9. We get x equals 27. And if you plug it in, 27 divided by 9 is 3. 3 minus 4 is -1, so it's valid. Good? All right. Next one. Next one's a cube root. I'm not sure if you guys will. I mean, we've done it before, but let's say if you guys can do this next one. We got the cube root of 2x equals 4. So see if you guys can solve for this one. So how do I get rid of this cube root here? What did you guys do to get rid of the cube root? Raise it to what power? Third power. Shh, quiet please. We're left with 2x equals, what's 4 to the third power? 64. And then what do we do after? Divide by 2 gives us 32. And then you have to check it because I do have a cube root this time. Anytime you have radicals, you want to check it just in case. So if we check it, the cube root of 2 times 32, does that equal 4? Shh, quiet please. Remember, do not do anything to the 4. Leave the 4 alone. Just simplify and see if it equals. So what is 2 times 32? 2 times 32?
64.
And the cube root of 64 is 4. Did that equal 4? Yes, so it's valid. Okay? All right, awesome. So I'm going to have you guys go ahead and try this next one. This one, pretty straightforward. Just combine the like terms and then get the x's on one side, get the numbers on the other. After you combine the like terms, then you move the x's on one side, the numbers on the other. So what did you guys move over?
Add 14 to 6.
Add 14 on each side?
To 6, yeah.
Oops, I put 4, but 14. And this gives you what, 20? 2x plus 20 equals 6x. You could have done the x's first too. So if you did the x's first, it's fine also. And then what do you do after? Subtract 2x gives you 20 equals 4x. And then what do you do at the end? Divide by 4, x equals 5. And then you don't really have to check it because, again, nothing in the denominators, and I don't have any square roots, so you don't have to check it. That is your final solution. Okay? You could plug it in if you want to and see if it's valid or not. See if each side is equal. Okay? All right. Next one, let me see. Next one's a quadratic. Maybe I'll walk you through how to do it, and then you guys can try to do it. Yeah? Okay. Shh, quiet, please. Shh. All right, this one, go ahead and copy this one. X squared minus 9x equals negative 20. Shh. Quiet, please. Okay, I'm gonna walk you through what to do, but you guys actually have to try to do it. Quiet, please. Eyes up front. So here, it's a quadratic. Anytime you have a quadratic with x's, you want to... Quiet, please. Here you would do an ax squared plus a bx plus a c. You want to make that equal to 0. And then you go blank plus blank blank times blank. Okay? Then you go put it into the binomials equals 0. And then you're going to get like a x equals something, x equals something. Okay? So see if you can get your 2 answers this time. Shh, quiet, please. Some of you guys said the answer was -4 and -5. But you probably forgot to do this. When you get here, remember you have to split it in half. Make each one equal to 0. So if I make x minus 4 equals 0, if I solve for x, what's x going to be? 4. Because you add 4 on each side. This one, x minus 5 equals 0. You add 5. That gives you a positive 5. So your 2 answers are supposed to be positives, not negatives. No, you had negatives on your whiteboard. I'm blind, but I'm not that blind.
That means I don't know.
All right, guys, that's friend. If you have this squared, my pen's like that. Shh, quiet, please. Eyes up front. If you guys see this squared right here, this tells you should have 2 answers. See if you can get 2 answers for this one. You guys need to divide by 2 first. And then we get x squared equals, what's 50 divided by 2? And then how do I get rid of a square of a square? Square root both sides. So those cancel. And I get x equals, what do you do every time you have the square root? You have 2. I can have a plus or a minus 5. Shh. But shh, when you check it, both of them are valid. Shh. When you guys check, if you check, both of them are valid. Because if you do 2 times a positive 5 squared equals 50, what's 5 times 5? And 25 times 2 is 50. That equals 50. This one is valid. If you check -5, 2 times -5 squared equals 50. What's -5 times -5? Positive 25 times 2 is still 50. So both of them are valid. Your 2 solutions should have been 5 and -5. Both valid. Okay? So anytime you see the squared means you should have 2 answers. Okay? Just like this one had a squared, that means you have 2 answers. The degree tells you how many solutions you should have. Okay. The last part of the lesson is just determining if it's extraneous or not. I am going to give you a solution. You just have to tell me if it's valid or not, okay? So as a reminder for square roots, it's extraneous if you get a false statement or imaginary numbers. If you have rational equations, you just can't divide by 0, okay? Shh. So I'm going to do the first example with you guys. Go ahead and copy this one on your paper, please. You should be at the bottom boxes that says determine if it's valid or extraneous or something like that. Shh, quiet, please. You're copying this down on your paper. Square root of x plus 4 on the outside equals 1. And you have a semicolon here with a x equals 9. So what does the x equals 9 mean? So here the directions say determine whether the given solution is valid or extraneous. So I'm telling you, this is the possible solution. You have to determine if x equals 9 is valid or if it's extraneous. So in this case, I have the square root. So anytime you have the square root, that means you go plug it in and check, okay? You evaluate for x equals 9 in order to check if it's valid or extraneous, okay? So we're going to plug in, we have the square root of x is 9 plus 4. Does that equal 1? When you're checking, remember, you don't do anything to the 1, leave the 1 alone. So what's the square root of 9? 3. And 3 plus 4 is 7. Does that equal 1?
No, not valid.
No, so therefore x equals 9 is extraneous solution. So you would write x equals 9 is an extraneous solution. So the directions for these is just determine if the given solution. So I'm telling you the solution. You don't have to go do the work to solve. You're just doing the checking part. Okay? So I'm going to have you guys go ahead and try the next one together as a group. This one, copy this next one, and you guys are trying to see if x equals negative 10 is valid or extraneous. Shh, quiet, please. Okay, this one, if you check, you're plugging in the square root of negative 10 plus 11. Does that equal 1? What's 11 minus 10 is 1. Square root of 1 is 1. Does that equal 1? Yes, so x equals negative 10 is a valid solution. Okay? Awesome. Okay, the next one is going to be the rational equation. So I'll do the first one with you guys, and then you can do the last one. So this one, go ahead and copy. We have 2x plus 2 over x equals 1. 2x plus 2 over x equals 1. And then you get x equals negative 2. Shh. Quiet, please. Shh. Okay, so here my given solution is negative 2. You do not have to you could plug it in, but what type of equation is this? Notice I have a denominator with an x. Because I have a denominator with the x, this is the one you check the LCD and the excluded values. So what do I have in the denominators? 1 and x. So my LCD is only x. What's my only excluded value? X cannot equal... X cannot equal 0. So did I get 0 from my solution? No. This negative 2 is not an excluded value, so negative 2 is actually valid because it's not an excluded value. Okay? So x equals negative 2 is a valid solution because it's not an excluded value. It's not an excluded value, so therefore it's valid. The other way you can do it is actually plug it in and check to see if it's okay. If I plug in like 2 times negative 2 plus 2 divided by negative 2, does that equal 1? Shh. 2 times negative 2 gives you what? Negative 4 plus 2 divided by negative 2. So that's negative 2 divided by negative 2. That does equal 1. So these are equal, so it's valid. Okay, that's the other way you can do it, but that just takes longer. Just look at the excluded values if you ever have anything in the denominator. Okay, so I want you guys to go ahead and try with this one now. Just copy it. Shh. Again, you're not solving. All you're doing is just checking if this is valid or extraneous. Look at the LCD. What is the LCD? What is the excluded value? And then check. If your answer is the excluded value, then it's extraneous. What is my LCD? What's in the denominators? X plus 1 together. Yes? Okay. Then what's the excluded value? What would make that a 0? A negative 1, right? If you subtract 1, it gets you negative 1. X cannot equal negative 1. Is that then, check this solution. Is this an excluded value? Yes. So I cannot equal negative 1. So therefore, this is extraneous. Okay. Your solution, you should have said x equals negative 1 is extraneous because it is an excluded value. Okay, that should have been your conclusion, is that it's extraneous because you have an excluded value. And that's all you had to do. You didn't have to go try to solve it. It was just, is it valid or not? Okay? All right, that is the end of the lesson. So for the rest of the period, you guys have 20 minutes to do the homework. So your homework is the next page over. You guys have 20 minutes to do it. You are working quietly for the rest of the period, okay?